Allora, il prossimo speaker lo racconterò sempre in italiano, anche se il suo talk sarà in inglese. Parliamo di budget, parliamo di costi, parliamo di tagli, tutti argomenti che non sono particolarmente divertenti in ambito tecnico, ma con questo talk Kunal ci racconterà, in quanto diciamo developer relations manager, in che modo possiamo cercare di risparmiare tempo e risparmiare soprattutto il budget con alcune delle best practice da utilizzare all'interno del mondo di Kubernetes. Quindi vediamo come il monitoraggio può esserci utile all'interno di questo tool di orchestrazione per risparmiare un po' di tempo e anche un po' di soldi. Grazie per il contributo, andiamo con la registrazione.
Hey everyone, welcome to my session and I hope you're having a great event. Today we're going to talk about Kubernetes cost monitoring best practices. A little bit about me, I work at Cibo as a DevRel manager and I've been involved in open source community since I was in my freshman year. I'm a CNCF ambassador and I run my own communities where I teach folks about cloud native stuff and I've been attending a lot of events. I love getting involved in communities and helping people and learning from them. So I'm really excited to be here. And I also love skydiving, which is, I work in the cloud, sometimes literally, little joke there. But anyway, so talking about Kubernetes cost monitoring and cloud cost monitoring best practices. But before moving forward, we're going to talk a little bit about the challenges, right? And I work at Cibo, we're a cloud native service provider. So obviously cost is a big factor for us and other cloud providers as well. You get customers are like, hey, why should we pay for this or that, or how much does this cost? Not just for Cibo, but any cloud provider you go to, cost is always a topic of discussion. So we did a recent cloud provider survey, and in that survey we surveyed around 100 companies using the hyperscaler providers, and 45% of the firms indicate that there was a growing pressure to reduce these cloud costs, and 37% have been stung by like unexpected costs in the last 12 months, and 34% feel locked into their cloud, be that like interest charges or something like that, and 65% said that it's like too expensive for them to leave. All right, so we're going to talk a little bit more about let's talk about the challenges that folks face. So the first one over here is the inability to track cloud spends. So cloud sprawl, for example, or like a sudden bill, it's like a constant problem that many enterprises encounter. Basically occurs when a company is unable to thoroughly track and evaluate its cloud computing resources. It also refers to the unchecked sudden increase in cloud instances or services or even providers. The next one is more on the team level. So conflict between like teams. So managing cloud resources and cloud costs, it shouldn't be handled differently by each team member or like department inside the firm. And that's also one of the challenges that people face. There's one more thing called overprovisioning. So it basically means that you acquire more resources than the enterprise requires. So, in order to support like the workloads of the organization, better known as it's better known as over provisioning, right? So you acquire more and more resources. So the result for this is that it results in wasteful use of cloud resources and unforeseen and sometimes unnecessary costs, because you're actually not using these resources. It's going to waste. And the next one, I'm sure many people would be familiar with it. It's called complex billing. So there's a little meme over here. So cloud bills, are frequently unintelligible for the finance team, if you will, due to the complexity and the technical, all the jargon that it has. So that's also one of the, there's events like, some of the big cloud conferences, you'll see like 4 to 5 startups who are just focused around making this thing simple for people, like reducing the complexity of your cloud bill or something like that. So that's definitely a huge problem and challenges that people face. Next one is monitoring. So, it's also pretty self-explanatory, like, monitoring the resources and all these other things we mentioned, which we'll talk more about later when we talk about the best practices. Let's talk a little bit about what your goals are. So we talk about the challenges. We talked about the challenges. We talked about, what the community thinks in the surveys and everything. So let's talk about, before we move forward with the best practices, we have to talk a little bit about what is your goal. Okay, when you think of reducing your cloud spend or whatever, you have to think about like what is the goal when we talk about reducing cloud spend. So it's just like, okay, you're having a meeting with your team and you're like, okay, we have this huge bill. Is it because we are running more instances, or is it because like something went wrong, or you want to reduce your cloud spend? So it's not like you just make your product not very good. So the goal is to reduce the costs while also maintaining the same speed of rendering and the quality of service, right? So think about how your organization is currently like operating in the cloud, and does your enterprise have like a well-defined cloud operation model? Do you have like a formalized have you formalized like a FinOps organization or something like that? So the cloud cost optimization, it does not have to be complicated, even though we're talking about how complex the costs and the bills can be. It does not have to be complicated when we talk about the optimization part, but it does require a disciplined approach that is going to establish good right sizing habits and continuously drive insights and action through analytics to lower your cloud bill, right? Cool. So next we're going to move forward and we're going to talk a little bit about the best practices. So first things first, you have to think about how cost monitoring tools work. If you're talking about reducing your cloud costs, we're talking about monitoring tools, right? Monitoring is key, something I want you to take away from this session. So there are many tools out there which is going to help you do that. I'm just going to mention like open source projects and stuff, for example. So again, you might be familiar with all of these like solutions that there are in the market. So you have to think about how these cost monitoring tools actually work. So essentially, what this basically means that these tools are basically translators between the resource consumption and the cost. For example, you say like, okay, this pod is consuming 50% of a node in 1 hour. So that basically means that it will cost 50% of that node's cost. Okay, there's a translation between the consumption of the resource and the cost. So that's what essentially the cost monitoring tools are. And the Kubernetes monitoring tools, they use it as a bridge. For example, like Datadog or Prometheus and like others that offer like very deep monitoring solutions for Kubernetes, and it provides very like granular consumption metrics and all these other things. So they use these Kubernetes monitoring tools as the bridge, right? The next thing is like node cost. So for example, cloud providers, APIs, and like billing files. So you just need to decide how the cost is split between, let's say, memories and CPUs and all these other things. Okay, so when we join these two together, we will get the result of the cost per pod. Okay, for more complex entities, you can have like cost per deployment, per namespace, cluster, and you can even have like labels such as like customer, right? So that is something also we'll talk about in this session. So now that we know how cost monitoring tools work, the next best practice I'd like to mention over here is set budgets, in your organization for specifically like specific projects and specific teams and specific domains and things like that. The next one is unused and unattached resources. So the easiest way to optimize cloud cost is to look for unused or unattached resources. So oftentimes an administrator or like a developer might spin up a temporary server to perform like a function, just test things out, and then forget to turn it off when the job finishes. If it has happened with someone, all the things I mentioned right now, just if you can relate, raise your hand. And another common use case, the administrator may forget to like remove some storage attached to the instances that terminate. So this happens frequently in departments across the companies, and the result is that your organization's bills will include these charges for resources they once purchased but are no longer using. So a cloud cost optimization strategy should start by identifying these unused and completely unattached resources and remove them. Okay, so that was about unused and unattached resources. Next practice is idle resources. So what are idle resources? An idle computing instance might have like a CPU utilization of let's say 1 to 5%, but when an enterprise receives a bill for 100% of that computing instance, this is a significant waste. So a key cloud cost optimization strategy would be to identify such instances as well and consolidate computing jobs onto fewer instances. The next one is it's also one of the best practice, reserved instances. And these are basically prepaid compute instances that offer significant pricing discounts. So when you're purchasing reserved instances from a cloud provider, you select like an instant type and typically like a region or the availability zone, and you commit to using the instance for a period of like 1 to 3 years or something like that. In exchange, most cloud providers offers like discount to like 70-75%. One thing I want you to note over here is that because you pay upfront, you have to do your you must do your research and plan based according. How do we plan for the future? By looking at the history. So plan based on your historic instance usage, because you're paying upfront for a period of time, for a few years or something like that. So that's the point that I would like to note over here. Next one is like spot instances. And unlike reserved instances that we just saw, spot instances are available for like last minute purchases. However, these instances are like unreliable because they're not always available and can like sell out quickly. So, they can help you save a lot more on like your AWS bill or whatever, or Azure spends and things like that. Yeah, but if you get a nice price is right, you can purchase it for immediate use. And that's basically about it. It's ideal for like web services, containerized applications, or like other stateless or fault tolerant workloads. The next best practice is heat maps. So a heat map is basically a visual tool that shows peaks and valleys in like the computing demand. So basically, this information can be valuable in establishing the start and stop times to reduce costs. An example for this can be that a heat map can basically indicate that whether the development servers can be safely like shut down on weekends. Folks not have holidays on weekends. So heat map can show that, and you can shut down these servers. Similarly, according to regions and according to like the specific days and times and all these other things, heat maps can definitely be a great visualization tool. The next one is the right size. It's difficult. This one is a tricky one. It's difficult to size instances correctly when the cloud administrators have like, more than like millions of possible combinations to choose from. And in addition to like server size, you can also like optimize your servers for other things, other resources like memory, database, computing, graphics, storage capacity, throughput, and a lot more. So what I recommend having like different size nodes for different various workloads. Software licensing costs. Now this is also an important one, and it's a major component of cloud operating costs. Manual license management is challenging. It increases the risk of like paying for unused software licenses, for example. But you can find various commercially and publicly available in like the marketplace applications of various cloud providers. So these license tracking tools can identify idle or unneeded licenses to help you reduce your spending. The next best practice is a cloud native design. So replacing the existing cloud systems with a more cost efficient ones to leverage the cloud specific capabilities. So an example for this is that you can design a system with auto scaling to ensure that you only pay for the servers that you use, and your design should balance the performance, cost optimization, and other considerations based on your organization's priorities and objectives. So an example for this can be like a fast DevOps pipeline in the cloud might not reduce costs. So should balance it. Balance the performance, the cloud optimization, and also take into other considerations. The next one is a pretty interesting one, which is multi-cluster. Now, Kubernetes multi-cluster, on the other hand, it refers to, what does it mean? Basically means you create multiple clusters when you're running workloads and defining the resource isolation, the continued availability, and the resource flexibility, and all these other things. So Kubernetes multi-cluster technology allows organizations to provision their workloads in several clusters rather than just one. And this is also known as Kubernetes multi-cluster orchestration. Now, some of the actions that the teams can consider in order to optimize their cluster resources and keep the Kubernetes cloud costs, checked. Basically, you're managing your node density. So basically, the number of nodes running in a cluster. This is critical when we talk about cost optimization. So it's important to ensure that your team is running the right size, number, and the type of node in your Kubernetes cluster. The next one is like say maintaining the pod sizes as well. So to manage the cost of your Kubernetes cluster, resource requests and limits can be used to avail like enough resources for optimal performance, but not much of like a wastage. So you can examine your pod usage and application performance over the time to consider, what's the right size for your pods through how to consider right sizing your pods through requests and limits. The next one we spoke about it recently, which was auto scaling. So the Kubernetes features auto scaling capabilities to keep right side cluster resources running, such as the size and the number of pods. So and number of pods and like number of nodes and clusters, it all depends on your need, right? So features like horizontal pod autoscaler and cluster autoscaler are all you need to keep your clusters fit for on-demand needs and to efficiently manage your costs. The next point is also one of my favorite ones, which is multi-cloud. Prevent vendor lock-in. Do that. Some of the enterprises deliberately seek out for multi-cloud solutions to avoid vendor lock-in. And I think this is very important. It can be a little bit risky initially when you get, let's say, free credits or whatever, but after a while you realize like, okay, I was stuck in vendor lock-in, I can't move my data around without paying a hefty fee or whatever, right? Charges and all these other things. So we talk about multi-cloud, talk about like, should companies even consider a multiple approach, or why should we do that? First point is like, don't put all your eggs in one basket, and there's not like no like one size that fits all, because there are like varied workloads, and we talked about it right in the previous slides. And we talk about performance, we talk about cost, we talk about environment type, and various departments may have different needs and things like that, cost efficiency and all these other things. So you should definitely consider a multi-cloud approach is what this slide basically recommends. And if you talk about like hyperscalers, for example, there are a lot of hidden costs along with hyperscalers, right? So that the true hidden price for AWS is coming from like the traffic cost. They sell like reasonably priced storage, and it's even like free to upload. Okay, so people will be like, oh, wow, that's pretty cool. But the catch is that when you get it out, you pay an enormous cost. So there are always hidden costs. Okay, maybe like some hidden costs available with hyperscalers. So do your research, and yeah, that's basically what I'd recommend. Talk about cost specifically from the providers. If you talk about the big three hyperscalers, so Amazon leads the 200 billion cloud market, right? And you can see Azure is there, then Google Cloud is there, and then there are some other companies. So the question you should ask yourself is, three companies leading the market, is this a dangerous place to be in? Because 82% of the cloud spend is with 8 large companies, so so much with so few. Is this a risk? And there's one more point that I would like to mention is that the big providers, they are not always immune to outages. There was an Office 365 outage for 16 hours, Google London data center 6 hours, Cloudflare outage 2 hours, right? And these are the providers that were affected. So something that you can ask yourself. So we were talking about multi-cloud approach, and this is a continued slide for that. You can try to approach with like a smaller provider. If you talk about cloud costs, so for hyperscalers, you have to pay an extra like a few thousand dollars in order to just get that support. So also, why you should evaluate smaller providers. You probably don't need hundreds of services and products that the hyperscalers provide. A recent survey that we did showed that 20% using more than 15 services, 34% is using less than 5 of the hundreds of products. You can save money by predictable billing, no egress charges. You can take out your data, not pay anything for it. Complexity is reduced, ideal for smaller teams. Performance can be improved, efficiency can be improved. A more personalized service at not an extra cost, enhanced SLAs, and much more. The next best practice I'd like to mention over here is called multi-tenancy. So the phrase multi-tenant cloud, basically it refers to a cloud computing architecture that allows customers to operate in a shared environment, typically like a public or a private cloud. And the benefits include that the cloud vendors can provide like increased storage and greater accessibility for a lower price compared to a single tenancy. A multi-tenant architecture provides high levels of agility and scale, and capabilities can be rolled out across all customer locations easily, right? And it also eliminates the need for users to manage individual users to manage infrastructure and handle updates and maintenance and stuff, especially if you're using a managed service provider to act as a single pane of glass. There are a lot of cost benefits. Like we talk about, most importantly, like why multi-tenancy, it's like cost efficient. So an organization who needs to like access multiple cloud providers with a range of products will save money by working with a multi-tenant MSP compared to working with an independent like single vendor such as AWS. And a flexible approach like this is perfect for organizations that are like growing rapidly, especially as a provider, simplifies management and saves time with multi-tenancy. The next one is also a very important best practice that I would like to recommend is building a culture. Make cost a first class metric. So how do we do that? You can do that by promoting the idea of cloud cost within the organization and making it easy for everyone on the development team to see and understand the actual costs. Okay, so keep cost top of the mind as engineering decisions are made. To make cost like data more easy to understand, make sure that it is current, it has context, it can be measured, and there is a clear definition of what is good and what is bad. We talk about teams, we talk about culture, we often talk about like it's much more than just tools. Okay, there's unit costs associated with it, right? There's cost per customer, for example. So let's say you are having you're speaking to some people like in your meetings, like finance people. So give easy answers for the finance people and like C-level people about the business aspect of the cloud usage. Don't talk in cloud services they don't understand, right? And understand which customer is more profitable. Okay, talk about cost per customer. So talk about which customer is more profitable, who is the least more profitable, and it will also easily explain why your bills went up and if that's even a good thing. So how do we do the cost per customer thing? Understand the pod cost, understand the shared cost, tie it all together. So if you want to look at a formula, it will be like price per unit. The previous slide we talked about unit cost. So price per unit multiplied by consumed unit per customer. Okay, price per unit multiplied by consumed unit per customer plus number of like dedicated pods is equal to customer cost. Okay, so that's the cost per customer. Cool. This is one more slide I want to mention, which is like, took this from FinOut, which is also providing cost management solutions. So how much does serving X customer cost? Okay, so there are some patterns of analyzing cost of like a complex system. You split according to like the subsystems for analyzing, and can I allocate it to per customer already? Is there a metric that you can split it by? And from a product to an efficient product, take economy of scale for infra changes, tracking discounts, coverage per business units, and so many other things. So this will help you in understanding, which customer is more like valuable, they're more spending with your company, and which is spending less with your company. There's a lot more, we can talk on and on about this. Talk about like cost per. You can talk about cost per customer. We can talk about cost per feature as well. So hey Kunal, you want to build this feature? Okay, how much is this feature going to cost? What is and how much is the incremental revenue that this feature will bring in? Is it worth building right now, or is there anything else that would map to the business goals better right now? How much are the legacy decisions going to cost us? And so many other things like technical debt and all these other things, and revenue wise. So we talk about like cost per customer, for example. How much does a new customer cost in terms of like storage and compute or whatever, and the revenue and various segments, and if we can offer them discounts or price offerings, and so many other things. Are we losing money and something like that? We can also talk about cost per app. How much does it cost to run our app regularly? What are the margins and how much money are we making on the app? Cost per team, for example, how much is each team spending in the cloud? The revenue, how much is the company making? And the cloud cost, what is the annual cost of running the entire cloud? Cost per unit. So the definition of unit here varies based upon what you are selling and how it happens. But so the question you can ask is like, what is one cost per unit? What is the revenue per unit? What are the margins? Are there any opportunities to reduce this cost? So on and so forth. So many things we can talk about when we talk about cost monitoring, right? Time to market, for example. How long does it take for products to get featured on the market, and how much is it going to cost in terms of the work hours and things like that? And there's also like cost per cloud service. How much are we spending on storage and compute and database and other cloud services? So many other things, right? Cost of R&D. How much are you spending on R&D? How much are you spending on work hours? The technology cost. Is there the potential value in the outcome? And so many other things, right? So I'd just like to end this session. I hope you had enjoyed it with this quote by Albert Einstein. This is a very nice code, right? When we talk about cost monitoring, because it often gets complex. So code is genius is making complex ideas simple, not making simple ideas complex. So don't be afraid to talk with customers. Throughout our careers, the best software engineers we often identify are the ones that work with the customers to solve their problems. So sometimes you can um, sack a half years of development time just by learning that you can solve the customer's issues with a single line of code. So talk to people. And I think it's the best engineers are creating solutions for the real world problems. And that is something, solutions come when you actually get involved in the real world and you talk to customers like, okay, how can we help you? What are you struggling with? And things like that. That was it. And I had a great time speaking at the event. And if you have any questions, you can always reach out to me on Twitter. That's where you can find me. My handle is as you can see, my handle Kunal S TWT. And yeah, I hope you had a great time at the event, and I had a great pleasure of speaking at the event. And if you have any questions, feel free to reach out. And have a good rest of the time and rest of your event. And I hope you enjoy it. And yeah, thanks a lot for joining us.